gas laws. Let's understand about Boyle's law, which gives pressure and volume relationship. You can see the graph of pressure P versus volume V of a gas at different temperatures. You can see the graph of pressure of a gas P versus inverse of volume, that is 1 by V. So you can see the graph of P versus 1 by V for T1, T2 and T3 such that T3 is greater than T2, which is greater than T1. In this chart, you can observe the effect of pressure on the volume of 0.09 mole CO2 gas at 300 Kelvin. Thus, we can conclude that pressure is inversely proportional to volume at a given temperature. Let's take a question to understand the gas laws. A balloon is filled with hydrogen at room temperature. It will burst if pressure exceeds zero point 0.2 bar. If at 1 bar pressure, the gas occupies 2.27 liter volume, up to what volume can the balloon be expanded? Let's see the solution. According to Boyle's law, P1V1 equals to P2V2. If P1 is 1 bar, V1 will be 2.27 liter. If P2 equals to 0.2 bar, then V2 equals to P1 V1 divided by P2. V2 equals to 1 bar into 2.27 liter divided by zero point 0.2 bar, which is equal to 11.35 liter. Since balloon bursts at 0 point 0.2 bar pressure, the volume of balloon should be less than 11.35 liter. Let's understand Charles' law, which gives temperature-volume relationship. According to Charles' law, at constant pressure or when pressure is kept constant, the volume of a gas is directly proportional to the absolute temperature. You can observe this volume versus temperature graph for P1, P2, P3 and P4 such that P1 is less than P2, which is less than P3 and which is less than P4. Let's take another question. On a ship sailing in Pacific Ocean where temperature is 23.4 degrees Celsius, a balloon is filled with 2 liter air. What will be the volume of the balloon when the ship reaches Indian Ocean where temperature is 26.1 degrees Celsius? Let's see the solution. Here V1 equals to 2 liter, T1 equals to 23.4 plus 273 Kelvin, which is equal to 296.4 Kelvin. T2 equals to 26.1 plus 273 Kelvin, which is equal to 299.1 Kelvin. From Charles' law, V2 equals to V1 T2 divided by T1, which is equal to 2 liter into 299.1 Kelvin divided by 296.4 Kelvin, which gives 2.018 liter. Let us understand Gay-Lussac's law, which gives us pressure and temperature relationship. In this setup, you can see as the pressure is increased, temperature is also proportionately increased. Let us see the explanation of Gay-Lussac law. According to this law, at constant volume pressure of a fixed amount of gas varies directly with the temperature. Mathematically, pressure P is directly proportional to temperature T, that is, P is proportional to T, which gives P equals to kT, where K is proportionality constant. This implies P by T equals to K. You can observe the graph between pressure and temperature. Such graphs are called isochores for a gas. Here, the graph has been given for 4 volumes V1, V2, V3 and V4 such that V1 is less than V2, which is less than V3, which is less than V4. Let us understand Avogadro law, which gives us volume and amount relationship. Avogadro's law states that equal volumes of gases at the same temperature and pressure contain equal number of molecules. So, V1 by N1 equals to V2 by N2, and volume versus number of moles or number of molecules curve is a straight line. In this animation, you can see as the volume is increased, the amount, that is, the number of moles are also increased. At standard temperature and pressure, which is also known as STP, the molar volume of each gas is 22.71098 liters. Molar volume in liters per mole of some gases at 273.15 K and 1 bar, which is STP, are given here. For argon, it's 22.37. For carbon dioxide, it's 22.54. For dinitrogen, it's 22.69. For dioxygen, it's 22.69. For dihydrogen, it's 22.72. For ideal gas, it's 22.71. Number of moles of a gas can be calculated as follows. N equals to M by capital M, where small m equals to mass of the gas, capital M equals to molar mass. Therefore, V is directly proportional to M by capital M, which implies V equals to K M by capital M, which implies capital M equals to K M by V. This implies capital M equals to KD, where M by V equals to D, which is density of the gas. Let us see explanation of the Charles law. By Charles law, for each degree rise in temperature, volume of a gas increases by 1 by 273.15 of the original volume of the gas at 0 degrees Celsius. Let the volume of gas at 0 degrees Celsius is V0 and the volume of gas at T degrees Celsius is Vt. Then Vt equals to V0 plus T by 273.15 V0. This implies that Vt equals to V0 into 1 plus T by 273.15. This gives Vt equals to V0 273.15 plus T by 273.15. This implies Vt equals to V0 T by T0, where capital T equals to 273.15 plus T, and T naught equals to 273.15. The temperature T naught equals to 273.15 is called the absolute temperature scale or Kelvin temperature scale. Therefore, 0 degree Celsius equals to 273.15 Kelvin. Now, from above, Vt equals to V naught T by T naught. This implies Vt by V naught equals to Tt by T naught. If initial volume and temperature are V1 and T1 and final volume and temperature are V2 and T2, then by Charles' law, V2 by V1 equals to T2 by T1. This implies V2 by V1 equals to T2 by T1, which gives V1 by T1 equals to V2 by T2. This implies V by T is a constant. Let's call it K. This implies V equals to KT. That is, V is proportional to T or volume is proportional to temperature.